Hello, my name is Florence Ofori. I'm a candidate or student of the MSAIB class, and today I'll be talking to you about geospatial foundational models. So, why did I choose this topic? Well, firstly, this is something that I did in my prior work. I did similar things in my prior work. I did flood forecasting, locust prediction, building detection at Google Research. So it was more of using like geography related data, which is geospatial data to create machine learning models. So that's why we call it geospatial modeling. So this was the main field that I was in. I worked in teams that did this. And so I just wanted to bring my expertise of knowledge in the field to and relate it to what is happening in the class. So what are some key terms in geospatial modeling? We have geospatial modeling or machine learning, and I explained that earlier. So that's like using data about our physical environment to explain or to predict or even to detect what is happening in our environment. We also have remote sensing. And this is just using satellite imagery or satellites to capture scenes or pictures of our Earth surface. And then foundational models are quite familiar to us actually. A foundational model is, for example, is ChatGPT. So it's basically a model that is trained on a large corpus of unlabeled data, which is then fine-tuned to use it for various like use cases like um, language translation, um, like summarization, and so many other like functions, just like the way we see ChatGPT is able to do. Okay. So yes, like I explained earlier, so geospatial foundational models precisely are trained on vast amounts of unlabeled geospatial data, especially a lot of satellite data, but it can also be trained on different kinds of modalities, like text, like audio, etc. And it can also be fine-tuned for a lot of applications. What are some of these applications? They are numerous. There's natural disaster monitoring, there's disaster management, like post-disaster management. We can use the satellite imagery to we can get maps of satellite imagery and run some predictions to see which areas have been affected based on past disasters. We can use it to detect land change. How did the land change across time? We can even use it for like consensus um consensuses and then building planning or environmental planning of a city. If they had so many uses, we can use it in something called precision agriculture, which is used to help farmers know the exact amount of produce they're supposed to make in order to make at the highest amount of profit, and also which products they should be making more or less of. So the uses are endless. So what are some of the current geospatial data sources? Google Earth Engine, there's a product by Google called Google Earth Engine, and they have vast amounts of data resources. They also have like APIs for you to use. They have resources for you to use to process this data, build machine learning models, build prediction models. So it's a comprehensive system. We also have the NASA Earth data. So this platform helps you, gives you a lot of data relating to weather, soil temperature, soil moisture, and like so many other factors as well. We also have ECMWF, which is the European Center for Medium Range Weather Forecast. And this site has more data relating to probably hourly instances of weather, be it rainfall, precipitation, snow, so many weather weather measurements. And they also do predictions, so they can give you like about 6 hours in the future prediction, 12 hours, 24 hours, etc., etc. So all these places give you like quality data sources that you can use to train your geospatial models. So what are some of the current works on geospatial models? There's a release of a geospatial model created by NASA and IBM in 2023. So this model was created to and it's made open source to enable people to access geospatial data for free and build solutions using this model. Now we also have another one called Prithvi. It's a user-friendly version, so no coding experience is required because it's on a no-code platform. So some use cases for the geospatial foundational models, especially with relating to the HLS geospatial foundational model, is that like it's available on a platform called Hugging Face, which is a free an open source platform where you find like various models as discussed earlier on. You can also find Prithvi. Prithvi is on a platform called Earthblocks. And with this platform, it's a no-code platform. You don't have to be an expert in geospatial or spatial temporal data. You just have to go on there and use this platform. You don't need to know any code. So I'll encourage you all to try that out. So how is fine-tuning a geospatial foundational model different from fine-tuning like a large language model like ChatGPT? So usually for geospatial models and relating to the data type, you see that it uses like satellite images, geospatial coordinates, and etc. etc. So it uses different variables for fine-tuning and for training. Now, for large language models, they use more of text like words, sentences, files, documents, PDFs. So what is the training objective of a geospatial model? It's used to detect spatial patterns and segment, images. So it's used to detect like patterns on our physical Earth surface or even in the atmosphere. However, for large language models, the major goal is to perhaps classify text, answer questions, and so on and so forth. So what does the future of geospatial foundational models look like in a couple of years? Firstly, we'll be able to use and generate higher resolution imagery for better accuracy of what is happening on the Earth. Another advancement will be multimodal foundational models, which is being looked at currently by NASA and Microsoft for Earth. So this is when we'll be using different kinds of data, text data, for probably maybe gauge or measurements relating to our Earth, satellite imagery, audio files, and so on and so forth to create a very robust model. We also have climate change monitoring. Climate change has become a very hot topic nowadays, and we're looking at ways of using geospatial foundation models to predict what is going to happen in a couple of years. How are we going to make sure that our planet is sustainable and climate change doesn't become a very big problem that we have to handle as humans? So companies like Microsoft are looking at this. Copernicus is CPS is also looking extensively at this. So to conclude, I'd like to say a quote by Ray Kurzweil. He says, "The universe will wake up it will become intelligent and it will be saturated with our intelligence. This is the destiny of the universe. I can't wait to see the future of the universe where humans and technology merge and we will become and the universe will become alive. It will be such a splendor and we actually live in it. We're living this reality. Thank you very much.